Okay, guys, welcome back. Today we're going to be talking about trig equations. And actually, there are five different ways that we're going to look at trig equations. Number one, we're going to check whether a given number is a solution. Two, we're going to find all solutions for a trig equation. Three, we're going to solve linear trig equations. Four, we're going to solve just a regular trig equation. And five, we're going to do the same thing, but with a calculator. Okay, now the first thing I want to look at is I want to look at theta equaling pi over 4. I want to see if that works for the equation sine of theta equals 1/2. So what I'm going to do is I'm going to take theta, which is equal to pi over 4, and take this pi over 4 and plug it in for theta here. So this means we have sine of pi over 4 equaling 1/2. And so what we're going to do is we're going to take our unit circle and we're going to look for pi over 4 in the radians. And we're going to take our sine value, which is our y value, of that point and see if that equals 1/2. And actually, sine of pi over 4 is equal to the square root of 2 over 2. And if you agree with me, that does not equal 1/2. So pi over 4 does not work, or is not a solution for the equation of sine of theta is equal to 1/2. Okay, so now what I'm going to do is I'm going to look at theta equaling pi over 6 for the same equation. Okay, so like I said for the previous one, we're going to take our theta, what it equals, and we're going to plug it in here. So sine of pi over 6 equals 1/2. And if you once again look at the unit circle, our y value for pi over 6 is 1/2. And so a half does equal 1/2. And so pi over 6, we conclude, is a solution for our given equation. This works for tangent, cosine, anything else of that nature. Okay, so there's number one. Number two, okay, we want to find all the solutions of a trig equation. Okay, and so let's say we have cosine theta equaling 1/2. Okay, and what we want to do is we want to solve this. Now, with this, we kind of have to give some kind of general formula for the solutions. And we're going to have more than one solution. We're going to have at least 8 in this case. And so what we first want to look at is we want to look at the period. Okay, the period is 2 pi. Okay, so our interval that we're dealing with is between 0 and 2 pi. Okay, and with this, there are two angles in which cosine equals 1/2. Okay, remember 1/2 for cosine, it's going to be our x value, so we're going to be dealing with the right side of this because our x values are positive, positive here, positive, negative here, negative, negative here, and negative, positive here. And since cosine of theta is equal to a positive 1/2, we're looking over here at the x values. Okay, so we're going to be drawing our two triangles. Okay, and we're talking about cosine of theta equaling 1/2. So if this is theta and this is theta, adjacent over hypotenuse. So this length is 1, this length is 2, this length is 2. So this point right here is 1 and a number. This point is 1 and that same number, but negative. Okay, so here we have our two triangles. Okay, now because the cosine function has a period of 2 pi, then the solution can be given by the general formula. Now, if you, real quick, before I talk about that, skip something on my notes. Now, if you remember cosine of a half, this is pi over 3, and this is 5 pi over 3. based on the unit circle. So our formulas that we're going to be dealing with are going to be dealing with theta equaling pi over 3 plus 2k pi, the 2 pi coming from the period, and the k is our constant, or theta equaling 5 pi over 3 plus 2k pi. Okay, so here are our two equations. That k is, like I said, it's any integer. So here we have, let's just look at 8 different solutions that we could have. Okay, let's say first if k equaled -1, then what we would do is we would plug it in here, and so for this guy we would have pi over 3 plus 2 times -1 pi, so pi over 3 plus -2 pi over 3. Okay, so that we would have pi over 3 minus 2 pi, which is over 1. Okay, so if we make the denominators the same, this becomes a 3, this becomes a 6, so this is -5 pi over 3. Okay, that's for this equation. Then our second equation is this guy, so it's going to be 5 pi over 3 plus 2 -1 pi. This is, like I said, k is -1. So we have 5 pi over 3 minus 2 pi, which is over 1. Change the denominator, so 3 and 6. So 5 pi minus 6 pi is -pi over 3. So here are two of our solutions. Okay, we need 6 more. So let's say k is 0. If k is 0, then this whole thing is 0, and this whole thing is 0, just leaving us with pi over 3 and 5 pi over 3. Okay, so far now we have 4 solutions. Okay, the -pi over 3, the -5 pi over 3, regular pi over 3, and 5 pi over 3. Okay, so then we plug in another number. Let's say that number is 1. Okay, if we plug a 1 in here, that just leaves us with pi over 3 plus 2 pi, which gives us 7 pi over 3. And then if we plug in a 1 here, 5 pi over 3 plus 2 pi, which is 6 pi over 3, that gives us 11 pi over 3. Okay, and then let's say we plug in 2. If we plug in a 2, that gives us 13 pi over 3 and 17 pi over 3. You can plug in any number you want, but, let's say we wanted to find 8 of the solutions. There would be 8 of the solutions, the 4 prior to me erasing, and these 4 here. Okay? And so that's it for finding all the solutions for a trig equation. There are much more. You can plug in any number you want for k, and it'll give you 2 solutions. So theoretically, there's an infinite number of solutions. We just listed 8 that we could come up with. Okay. Now let's say that we wanted to solve, this is number 3, let's say we wanted to solve a linear trig equation. Okay, so let's say that we had this equation. We had 2 sine theta plus square root of 3 equaling 0. Okay, and another piece of information, we need to know that theta is greater than or equal to 0, but less than 2 pi. Okay, so this is only one time around the unit circle. So what we want to do is we just want to solve for sine theta. Okay, to solve for sine theta, we just work this out like it's algebra 1. We subtract square root of 3 from both sides. So we have 2 sine theta equaling negative square root of 3. Divide both sides by 2. So sine theta equals negative square root of 3 over 2. Okay, now negative square root of 3 over 2 in the interval, theta is equal to two different numbers. Okay, this negative 3 over 2 is going to be, since we're dealing with the y values, it's going to be in quadrant 3 here, in quadrant 4 there. So if we are dealing with negative 3 pi over 2, based on our unit circle, in quadrant 3, that is 4 pi over 3. And in quadrant 4, that is 5 pi over 3. Okay, so based on our unit circle, there are our two answers. Okay, so let's look at one more equation. Let's look at one that is a little bit more difficult. I wasn't going to go through this one, but I'm really feeling that I should. Let's say that we have sine of 2 theta equaling a half. Okay, and once again, 0 is less than or equal to theta, which is less than 2 pi. Okay, so within this interval, this sine function, sine of whatever equaling half, happens at pi over 6 and 5 pi over 6. Okay, so since the period is 2 pi, and we're dealing with 2 theta equaling a half, we, just like our example number 2 for finding all the solutions for a trig equation, we're going to say 2 theta is equal to pi over 6 plus 2k pi, and also 2 theta is equal to 5 pi over 6 plus 2k pi. Okay, now we want to get theta all by itself. So if we divide by 2, change the color, that means we divide this guy by 2 and that guy by 2. Divide this by 2, that by 2, and that by 2. Okay, so this gives us theta equaling pi divided by 6 divided by 2 is pi over 12, plus these cancel out, giving us k pi. Okay, same thing here. So theta equals 5 pi over 12 plus k pi. Okay, so now we have our two equations. Okay, if we wanted to give 8 possible solutions as well, just like we did in the previous one, I'm going to rewrite our formulas up here. And what we're going to do with this, once again, we're going to plug in different numbers for k. To give us 8, I'm going to plug in -1, 0, 1, and 2. Because there's 4 here, I plug in 4 to this guy and 4 to that guy, which 4 and 4 is 8. So if I plug in the -1 to this guy, I end up with -11 pi over 12. If I plug in the -1 to this guy, I end up with -7 pi over 12. Okay? And then when you plug in a 0, you get the same thing. So you end up with pi over 12 and 5 pi over 12. You plug in a 1, you end up with 13 pi over 12 and 17 pi over 12. Plug in a 2, you end up with, I believe, 25. Yeah, 25 pi over 12 and 29 pi over 12. Okay, and so here are some solutions. Now we just want the interval from 0 to 2 pi. Okay, from 0 to 2 pi. So that eliminates our negative. Okay, so that gets rid of this guy and that guy. Okay, leaves us with pi over 12 and 5 pi over 12, as well as the 13 pi over 12 and the 17 pi over 12. If you look at this guy and that guy, those are bigger than 2 pi, so we get rid of them as well, leaving us with these two and these two as our answer. Okay, so my next example, we're solving a trig equation. So let's say we have the equation tan of theta minus pi over 2, and this equals 1. Okay, now with this example, once again, we need our periods, so 0, theta less than 2 pi. So what we want to do is the period of the tangent function is pi. Now, since tangent functions have a value of 1 when it's pi over 4, okay, pi over 4, it does this, and this, and this, and this. Actually, it's just those two. Since it equals 1, then we are going to be using the equation theta minus 1 pi over 2 equals pi over 4 plus k pi. Okay, once again, k is any integer. So if we add pi over 2 to both sides, this gives us theta equaling 3 pi over 4 plus k pi. Okay, so once again, we have an interval between 0 and 2 pi. So our answer has to be, greater than 0, less than 2 pi. So if we plug in a negative here, the negative 1, so 3 pi over 4 plus negative pi, which is the same as negative 4 pi over 4. That gives us a negative pi over 4. We can't have that. So we are going to look at k equaling 0. Now, if k equals 0, we're just left with 3 pi over 4. That works. Now, if k is 1, then this is 3 pi over 4 plus pi, which is the same as 4 pi over 4, which gives us 7 pi over 4. If we plug in 2, that gets too big. So our answer is 3 pi over 4 and 7 pi over 4. Okay? Now, I told you I was going to show you the trig equations with a calculator. However, I don't have calculator software on this computer, and I did not bring my graphing calculator with me. So I will have to show you that in class, which therefore ends our video for today. So once again, we're finished. Thanks again for your time and patience. Have a good day.